root, I don't know anything about that, but it's an x root of 9. You don't have a right to say the square root of 9. It's not the same. This is the x root of 9, not the square root of 9. So you cannot say, what is the square root of 9 is 3. You can't do that. You're gonna get it wrong. Now, before you can do anything, you've got a different equation here. Whenever you've got the root signs with x as our whatsoever a root, and remember, just look at that value inside the bracket and make sure you break it down further. Break that value down but you can literally, before you do that, you can say, okay, it's fine. You've learned about this formula, this rule, a square root of n power m is equals to. Now, the root of n, the root of n here, n root of a to power m, n root of a to power m. How do our aim is to remove the root sign. This root, you need to remove this thing. You don't want it. How do you remove it? You say, okay, a to power m over n. Come on, someone. This n is going to be my denominator of this base of a, and my m is going to be my numerator of this base of a. Then the root sign will be removed literally like that. Now, I'll check. 9 invisible. 9 we have got x root of 9. Remember, if there's nothing here, is 1. It's 1 that is invisible. Now, in this case, n is x, m is 1. Now, how do you remove the root sign? We say 9 to power 1 over x. That's how you break the root sign. You take this x to be my denominator and this 1 to be my numerator. Is m1 x and m1 x n. That's how you break down the square root. The root sides is equal to 2, 4, 3. That's how you break down the root signs in mathematics. It's like this, guys. This is the real stuff. Now, your next aim is to make sure your bases are the same. Now, before you do anything, just check the base of your 9. Okay, 9 again. Break that 9 further. How do you break 9 further? I'm going to have 3 squared again. You know what 3 times 3 is 9 again. Therefore, I'm going to have 3 squared. 3 squared is 9. 3 squared is the same as 3 times 2. 3 to power 2 is the same as 3 times 3. Which means 3 multiplies itself 2 times to give us 9. I'm going to have 3 squared. It was 3 squared. Remember, we've got 1 over x multiplied by 1 over x. You must remember that is equals to 2, 4, 3. Okay, guys. I want to get 2 over 1. Before you remember, you've got x, so you cannot you don't apply reciprocals if you've got a variable. You don't apply reciprocals if you've got any variable as an exponent. You don't apply reciprocals if they are variables on your exponent. It will be wrong. In this case, just combine them. It's about numerator times numerator, denominator times denominator. If this is our exponent, multiply this by exponent. To be left with only one exponent, not 2 exponents. 1 exponent. Hurry. 3 to power 2 times 1 is 2. 1 times x is x. That's how you do it. Because of this x, you can't do reciprocals. Now, break down 2, 4, 3. Our aim should be that let the bases be the same on both sides. The situation now is allowing us to have same bases. After you have simplified the equation, make sure your bases are the same. Now, my aim is to have a base on my right as 3. Why? Because 3 consists of a variable, and we want to be left with this variable on one side. Therefore, my aim should be that let there be 3 on my right side, just like on my left side, because 3 cannot be simplified further. It means I can have 3 on my right. How do you make it possible? You test drive on your calculator. You can say, okay, what is 3 to power 5? You can start there. 3 to power 5. Okay, before that, you can say 3 to power 2 is 9. Okay, What is 3 to power 3 is 27. What is 3 to power 4? You test drive. This is 81. What is 3 to power 5? To save time, is 243. 3 to power 5 is what? 243. That means 3 to power 5 is the one I want. And my aim is to have bases that are the same. 3 and 3 are the same. 243 is the same as 3 to power 5. They are the same. If my bases are the same, if these two are the same, you equate the exponents. If my bases are the same, you do what? You equate the exponents. What are my exponents is 2 to power x and 5. When I have 2 to power x equal to 5. Now, x as we have a fraction here. How do you break down a fraction? If you've got equal sign in between, you cross multiply. For you to break down a fraction, you cross multiply. 2 times 1, you cross multiply. Another 2 times 1, x times 5, and you cross multiply. I hope I'm clear. 2 times 1 is 2, x times 5 is 5x. I give a solve for x. How do you solve for x? I give a we want to be left with x on one side. We divide both sides by 5. Therefore, this 5 divided by 5, we are left with x on one side. Therefore, x is equals to this thing, 2 over 5. Then you are done, guys. You are done. You are literally done if you do these things. Hope I'm clear. I hope I'm clear on that one. I hope my leg term, to be my middle term. I'm writing it in a good order so that you can understand. Now, where I see 2 to power x, I put in k. Now, I see 2 to power x here. Here's my 2 to power x. Here's my 2 to power x. I put in k where I see it. I put in what? K. Hurry. K. Here. K. Remember, if we got squared, we have 2 more. Think about k squared. Minus. Remember, let me just bring back those 9. I think it was. Okay, let me just write it like that. 3 squared times what? Times. I need the 2 to power x equal to k here. Times k plus 2 to power 3 equal to 0. Level, guys. Yeah. I think this one is proper. I hope we are clear how to use k method. Hope we are clear how to use k method. So therefore we've got k squared. Here what's about 3 squared? 9 again. 3 squared is 9. 9k plus 2 to power 3 guy 8 plus 8 equal to 0. Then we've got a quadratic equation in this case. I give us a quadratic equation. We've got a squared, ax squared plus bx plus c equal to 0. In this case, a is next to k squared. X squared is the same as k squared. B is negative 9. X is the same as k. C is positive 8, which is our constant. Then you've got 0 on the other side. It means this is a quadratic equation. I hope you can see it, guys. I hope you can see it. Now you're going to apply the equation on a quadratic. And quadratic is, in this case, about k. You don't say x, you just say k is equals to negative b plus or minus b squared minus 4ac over 2a. Okay, guys, this is how you do it. Now you substitute. And here are the negative. What is my b? And here are b negative 9. You just mention it, negative 9 plus or minus, open a bracket. What is our b? Is negative 9 again, squared. I get it squared. Negative 9 squared minus 4. What is our a? Is 1. A 1 here. What is my c? Is positive 8. You put positive 8, all divided by 2 much. What is my a? Is 1. Remember, these things 2 and 4 are formulas, and you must put everything. You don't forget this 2, this 4, this square root. They are very important. Then k is equals to, you put that on a calculator. Remember, we've got 2 solutions of k. We've got 2 solutions of what? Of k. When you put that on a calculator, your k, your k is going to be equal to the first value I'm going to get. I do guys. The first value I'm going to fraction negative b bracket negative 9 close bracket. You choose between plus or minus. Which one do you start with? You can start with positive plus square root of bracket negative 9 squared minus 4 bracket 1 bracket close bracket open bracket 8 close bracket. Our denominator is going to be 2 times 1 and don't forget to open brackets, guys. Then my first value with positive is, it gives me 8. K one is equals to 8 or our k is equals to, remember you've got two solutions of positive and negative. You go back to the calculator, you just remove that positive sign and put in a negative sign again. Yes, that's how you simplify quadratic equations. You remove this negative sign here, you remove that negative sign, you put in negative, you remove positive, put in negative there, then it's going to give you positive 1. K1 is equals to 1. I hope I'm clear on that one. Now guys, I just wrote the x. Remember, solve for x, not k. Solve for x. You're not done. Now, where you see x, you come back to the equation again. Where you see k, you put in the answer k. Where you see k, you put in this answer, this value. Where you see k, you put in 8. And we come back to this. We come back to let 2 to the power x equal to k. Where you see k, you put in 8. So totally 2 to the power x is equal to k. What is my k? Is 8. Or 2 to the power x. What is my k? My k is 1. Then solve for x here. Solve for x. Now this one involves different equations. Now it's very simple. 2 to the power x equal to 8 again. Now in this case you want to solve for x again. How do you solve for x? Remember, you cannot do the reciprocal. Remember, here we don't do reciprocals here. Why? Because we've got variables. If we had no variables, we're going to do reciprocals. But if you have variables, you make sure that the bases are the same on both sides. Now, what are factors of 8? Which number can multiply itself to give us 8? Remember, 2 is a factor of 8. 2 is a factor of 8 again. It's part of factors of 8. Now I can say 2 to the power 3 equal to 8. Also I can have 2 to the power x equal to 2 to the power 3. Remember, your bases must be the same. That's all A. Therefore, if your bases are the same, you do what? You equate the exponents. If the bases are the same, you're gonna say x is equals to 3, a positive. You equate the exponents. That's our aim in this case. When you come back to another solution, x, get 2 to the power x equal to 1. Remember? So we're gonna have 2 to the power x again. Remember, any number to the power 0 is 1. And our aim is to make sure that the bases are the same. Now, I know what 2 to the power 0 should be 1. Because any number to the power 0 is 1. Any number to the power 0 is 1. And our bases should have equal signs, should have same sign. In this case, it's positive and positive. Our equation is real. Any number to the power 0 is 1. If we had 3 to the power x here, you are going to say 3 to the power 0. If we had 4 to the power, if we had 4 to the power x here, 4 to the power x on my left, we're going to have 4 to the power 0 on my right. Your aim is to have same bases, but if you've got 1, you can write in, as long as the bases are the same, you can write a number that will make it possible for you to make sure that your bases are the same in this case. Therefore, x1, you equate the exponent like x equal to 0, then you're done. That's how you solve it. Hope I'm clear. Oh, this is the longest solution, guys. Longest solution ever. I hope I'm clear.